So welcome back to the Haas TL-1. You may recall that we improved the tool post. And how did we do it? We shimmed the T-nut so that the T-nut fit better into the tool post. We then added 2 pins into existing holes in the tool post and existing holes in the T-nut. And doing so, we had much limited rotation in the tool post, so it wouldn't, under heavy load, it wouldn't rotate. And that's good, and we like that. We tested it, and it works great. We're going to make it better. And one of the ways we're going to make it better is, well, the principal way we're going to make it better is we're actually going to drill holes in the tool block. I'll bring you in closer to take a look at that. But the tool block is attached directly to the cross slide, okay? And now the tool post is going to be pinned to the tool block. So instead of going from tool block to T-nut, then T-nut to pin, then pin to tool post, it'll go from tool block to pin to tool post. Let me show you what we're talking about. Okay, so you can see here's the tool post. The tool post is bolted down to the cross slide, and there's the T-nut. And the T-nut is hooked up to a post that goes all the way up to here, and here's the nut that tensions everything. So we added the pins between the tool post and the T-nut, but we're still relying on the fit of the T-nut in the tool block for that rotation. So we're going to improve that by putting the pins in here. So I'm going to start disassembly, and you can see what we're talking about real quick. This is the coolant line that's part of the V35tc. TC stands for through coolant. All right, here you can see the pins we put in. I need a little bit of hammeration here. A little gentle persuasion. So here you can see our pins, okay, which are glued in, and then you can see the shim, which is glued on. And that was the sum total of our improvements before. The T-block is screwed onto this post, and the top of the post, of course, is threaded to hold the tool block to the tool post. So the plan is we're going to pull these pins out, yes, after all that hard work, and then we're going to use one of the other pair of pinholes, and we're going to drill a hole here, and we're going to drill a hole here. And now, when we put the tool post down, these 2 holes are going to go over those 2 pins. So as far as location is concerned, it's going to be predominantly the pins. It doesn't even care that there's no T-nut in there. The T-nut and this stud is just going to be for holding it down. And location is going to be purely according to the pins. So the next step here is we have to take off the tool block. So let's do that. So as you can see, there's 2 screws holding down the tool block, and then there's 2 threaded holes in the cross slide, and that's it. There are no other locating features. So if we really had to get a little bit of adjustment here, we could wiggle this guy around and lock him down with the 2 bolts. Nominally, we would indicate this edge and make it exactly parallel to the cross slide. But if we need to tap it around for to compensate for some other error, we can do that. Off to the bench. Let's figure out how we're going to mark up these holes and get them drilled. So the first order of business is to figure out what the pin spacing is here so that we can get a game plan. So as you might imagine, I've already done a little bit of inspection on this when we started this project. Just going to put a little block under there so it doesn't roll away. And if we do the old caliper trick, which is measure a hole, zero it. I'm going to cheat by switching to millimeters and then measure this extent. We get a strong hint that this is a 70 millimeter spacing. So let's do that one more time. Zero. I'd say that's a pretty strong hint that it's 70 millimeters. So we could pretty well count on 70 millimeters here. I'm going to just check the other axis. Not that I've ever been burned before, but you know, there's your zero. And there's your reading. So it's looking a lot like 70 millimeters. So for the purposes of planning and layout, we're going to come over here and just mark this up. All right, let's just start with a little sketch. Here's the block. There's our big holes, and we're going to have we're looking for our holes here. So if we measure the hole block, we get 101.6. Okay. And we know that our hole to hole is 70. Okay. So that's 31.6 is the leftover between 101.6 and 70 millimeters. Call that 32. 32 divided by 2 is 16 millimeters. So from the edge of the block to that hole should be 16 millimeters. So we'll start there. .16 millimeters, and we'll make a mark. Okay, so there's our reference. Okay, right there. And now, from that hole, and just to make sure we don't lose it, right? And then from that hole to the other hole, we know that's 70 millimeters. So we're just going to dial in 70. And that is pretty much it. So, not super accurate, but that tells us where we're going. Now we could double check things again just to make sure we're not lunatics. Don't judge. That looks pretty good. So that's where our holes are going. Now we have 10 millimeter pins. I'm going to grab them. So for the purposes of illustration, let's just slide that guy over. let's see qualitatively how deep these are. All right, so there's a shorter pin. This is an M10 by 24 millimeter pin. And if we stick this in the hole, that looks nice, okay? So we're gonna need to drill a hole that's deep enough to accommodate this pin. And we're gonna do it at this location. Now that location is nice because it stays outside of the T-nut. And that'll work good. So the goal here is to drop 2 of these pins in. Okay, and pick up 2 of these holes. So now the question becomes, how do we locate these pins? And I've given this quite a bit of thought. Before we do anything, let's take a quick double check on the distance that we ended up with these pins. 70.05 or so. So that's another confirmation that we're heading in the right direction. We're over at the Bridgeport, and I want to go over how we're going to locate, drill, bore, ream these 2 holes. And I realized that we can go over to the surface plate and start making measurements of these hole spacings to get them a little more accurate. And then we can come over to this, this block, mark it out, come over to the Bridgeport, you know, and start doing all sorts of old school techniques to get that spacing exactly the same measurement as the measurement on the tool block. But then I realized that's not what's important. What is important is that they're the same. So, you know, a very wise engineer who I had the good fortune to learn under, Paul Brokaw, used to say, if you can't make it good, make it differential. So our job here is not to make it 70 millimeters, it's to make it the same as the block. So the plan, well, the other resource we have is we have a DRO that measures down to a 10,000th of an inch. Now, can we trust it? Not sure. It actually has a resolution of 2/10, not 1/10. So, not sure if we could really trust the DRO, but we'll see. So here's the plan. The plan is we're going to take the tool post and we're going to use the DRO to measure the distance between the holes, and then we're going to use the same measurements to locate our 2 holes, and we'll see how we do. That's making a differential, not an absolute measurement. That's what we want. We're over at the Bridgeport, and we're setting up to do a measurement using the DRO on the Bridgeport. Let's see what happens. Now remember, we're interested in these holes for this operation. This is the front or the operator side of the tool post, and these are the 2 that we're going to be using to pin. So just so we don't forget, we're going to mark that. Of course, there's no possible way we can get that wrong, right? So that's in metric right now. I should say we're using a very low resolution indicator right now, just to get in the ballpark. So we're just using eyeballs, Mark 1 Mod 5 eyeball. All right, now we have a reading. We could split the difference. I'm putting a little drag on the table and the saddle. That's starting to look good. So I'm going to use the 0 on the instrument to approximately mark that. I see a little chip in there. That's not helping. That's reading 0 and 0. So we have this axis, the y-axis, approximately dialed in. So now we can switch right over to the x-axis and just go right to 0. That's looking good. This one's a little off. And we are very close. So at this point, I want to go to a much higher resolution indicator, but I'm going to 0 my axes, and we have a place to start. So now I'm going to switch to a better indicator. This is an Indicall, pretty classic. And this is a Starrett, last word indicator. So this is a interrapid tenths reading indicator on a stem. So this will work with our Indicall. Remember, we already indicated to within about 0.002 here, so we can use that information to our advantage and just bring this guy in to touch. All right, we're indicating now. It's -1. That's -1. That's not bad. And this one's off a little bit. Let's see what that does. So let me just show you one important thing here. Is I'm putting a little tension on the gib, and then when I got it where I want it, I use the backlash to release any tension from the screw. And we have a little interaction here, so we're going to go after this. So if it seems like I'm being anal here, that's because what we're trying to do is use the location of the pins, that's 0.5 there, use the location of the pins as measured by the DRO. Okay, this is looking really good. So I'm going to go X, enter, Y, enter. Now, any motions I make now, I'm going to leave the locks on, just so they're dragging. Okay. This is a poor man's jig grinder here. All right, so let's check it. So I'm gonna try to get to a 1/10.5 here, which I know sounds crazy on a Bridgeport, but there it is. Okay, a little more tension on this on the friction lock. All right, so this guy is now zeroed on this hole. I'm going to go over. Notice on the DRO, it's reading 0.005 millimeters on X. I'm going to take that error out. Y hasn't budged. It's still on 0. Okay. Now, we're going to come out of the hole. We're going to move over, and we're going to pick up the second hole and see what we get. Okay, so we're just going to come out of the hole on the quill. And I know the quill is a wild card here. I'm going to leave a little drag on it. And we're going to move over 70 millimeters. And let's see if 70 millimeters is 70 millimeters. All right, the DRO says 70.000. And now we're going to just bring that indicator in, give it a little ramp here. All right, let's see what we're doing. That's plus 1/10. Whoa. So Y went minus 1.7 thousandths. This is minus 2/10. This is about minus 3/10. And this is about 0. Interesting. So let's examine Y first. We'll do Y first. I'm getting minus 1.7 and about plus 1.7. So we want to bring Y back in. So that's interesting that Y seems to be out. So let's bring Y in. I have drag on the lock, and I'm using my knuckle and tapping the handle. So now we're 0 here on Y. And this looks like about plus 1/10.5. Okay. Oh. I think we're going to go lower in the hole. I think we're getting a little bit fooled here. I know this makes for great video. So these holes might not be clean enough to do what we want to do. So I might use the pins. The pins have play in them, right? All right, let's continue investigating, right? That's why we're here. So let's go over to the pin and let's take a measurement at the pin as to how much wiggle is in the pin. I think that's going to be pretty interesting. And we'll set it to 0. So now we're just going to wiggle the pin fore and aft. Well, that looks like 4 thousandths of play right there. So you could make a good argument as to why the heck we're chasing tenths when we have 4 thousandths in the pin, and that's a really fine question. So now we have some decisions to make. Do we try to get this thing more accurate than the DRO, or do we just go for it? So the bottom line is that no matter what we do to the tool block, the tool post is going to have more play in it. So what we've learned is that the holes in the bottom of the tool post are pretty loose. We got 3.5 thousandths. And what that means is no matter what we do, we're not getting rid of that play. Now, what we did when we pinned the bottom of the T-nut, when we pinned the T-nut, you may recall that we used cyanoacrylate here to secure these pins, and that helped a lot. Well, in this particular case, we don't want to secure the pins because we might want to pull the pins out so that we could mess around with the tool post. Now, you know, Silo's Garage, Silo, did a really cool thing in that he made it so that he had many tooling balls in a circle, and he could lift the tool post and rotate it an index. I don't think we care about that. So I think what we're going to do is start preparing for making the holes and then testing a piece of scrap. Now, making the holes is not trivial because we have to take stock of what we've got available. We do have available, obviously, a spotting drill, an undersized drill, but we do not have a reamer. We need a 10mm reamer. So again, we have a decision to make. Should we make a 10mm reamer or order a 10mm reamer? Today, the grinder is busy making PFG stones. Do you have PFG stones? Head over to pfg.gg and learn more. That was a commercial. So it's not clear to me whether we're going to make a tool today. I'm going to check my reamer drawer one more time. We're going to have these very nice pins, which we've already mic'd, and they're a little bit plus from 10mm. So we're looking for a slip fit that doesn't require great feats of strength to remove. That's what we're going to do. I'm going to check my reamer drawer, but I don't expect a miracle. So I don't have a reamer. And besides, if I wanted to make a reamer, the grinder's busy. But I have a lathe. And I have this. This is a Criterion boring head, model S-1.5. And this is a really cute little unit where you can set probably thousandths here and then tenths here by rotating this this collar. This boring head has a 1/2-inch hole, and for example, it had this boring tool in it. And I know what you're thinking. You're saying, Spence, that's not a boring tool. That's an end mill. Well, look more carefully, Grasshopper. Okay, this is a modified end mill. And in fact, it's a special boring tool that I made the last time I had to improvise something. And this works shockingly well. But anyway, we'll set that aside because it's too big. And we looked around, and we have a gorgeous little Maritool carbide boring bar. So what if we took this beautiful boring bar and we put it in this boring head? We would have a nice setup for boring the hole that we need to bore. And all we need is a 1/4 inch to 1/2 inch bushing. Does that sound like lathe to you? I don't know about you, but that sounds like lathe to me. So we're just going to verify a couple of things here. Make sure we don't lose our pins. We're going to switch back to freedom units. And sure enough, you know, that is a hair under a 1/4 inch, and it's got flats on it. But if we drilled a 1/4 inch hole in a bushing and we made the outside of that bushing have a 1/2 inch OD and we split it, I think we'd have us a way to hold this tool. And of course, we'd orient this tool correctly and we'd have ourselves a boring situation. Ha! See what I did there? Boring situation. I think this is going to work. So I'm going to go find a piece of steel that we could use to make that bushing. Well, I'm back from the scrap pile, and I found a piece of this. What is it? Plain Jane cold rolled steel, but it is totally acceptable for a bushing. So I'm going to set up on the lathe, and I'm going to make a bushing that will do the job. Let's go do that. Okay, you might have picked up on this, you might not have, but in order to use the lathe, we had to remount the tool block and remount the tool post. Fairly uninteresting. We indicated this surface of the tool post square, and we're just ready to run. So we've got the piece of steel in the chuck. We're going to face it, turn it down to a nice fit for 1/2 inch, and then we want a nice 1/4 inch hole. So let's get to it. Okay, we're going to cut to 0.501. Go for it. What do you know? 5002. A little tighter than we want. Perfect. We'll take it. So we just did a little trick here, and the trick is we fired up tool number 5, which was our drill chuck, at slow rapids. So it got to the center line and it started moving, and then we stopped it. Now we're going to go find this surface and set that as our 0 point. So it's pretty obvious that we are not set up properly. Oh, I'm an idiot. So we've removed the tool post several times, so our X is all screwed up. So we're actually going to have to measure this again. Stand by. So we're kind of cheating here in that we have a nub at the end of our work, and we're just going to do it by eyeball. There's a million ways to do this, I know. That looks pretty good, actually. You know, sometimes the Mark 1 Mod 5 eyeball is pretty good. Of course, the tool height is okay. We just had to get the x-axis figured out. Now we got to decide how deep that how deep the spot's going to be. I'm going to do that kind of old-fashioned. $150 sounds good. So at this point, I'm going to pick a spot and I'm going to stop it, and I'm going to check distance to go. Okay, we're going to set up for drilling. Once again, we'll use the Mark 5 Mod 4 eyeball. Well, we just drilled the hole. It is a D drill. And now we're going to go in with a 1/4 inch reamer. And take care of that. Now keep in mind we drilled 1.25 inches deep, but we're not going to go that deep with the reamer. We'll go 1.1 because we like our reamer. Little Kickapoo Joy Juice here. That was pretty undramatic, right? Looks good. And by looks good, I mean we had the depth that we wanted. Let's do a test fit of our boring bar. Here's our boring bar. Oh, look at that. Lovely. Of course, it's now got gouge on it. Okay. Let us cut this thing off. So we're going to set our depth to 1.1 inches. Double check the width of the tool. I think I know what it is, but and I'm going to get a catcher, which is going to be a Q-tip, wooden Q-tip. So we're back on the bench with our bushing, and the fit is real nice, except at the end where we just cut it off, it needs a little deburring. So we're simply going to take the reamer we were using and rotating in the correct cutting direction. It's just going to go by hand. That's a good burr. I think we need a little help. Just going to use a tap wrench to give us a little holding power here. I'm going to go over to the vise and just hold this. So aluminum jaws for protection. And we're in. There we go. Okay. There's our burr. put this guy away. Give him a final wipe down here. Try not to lose the black, try not to leave the brown cutting oil on your tools. Kind of wants a little more deburring, but for the moment, we're just going to test this guy. So, let's see what we got. Nice, look at that. All right, we just have to modify it now so that we have a lockdown screw. So it's going to be operated in this mode where the insert is parallel to the ways of the boring tool. So it looks like our best bet is to slot this, not to drill a hole in this, but to slot the bushing. I think that would be best practice. Yeah, I think so. So there's a bunch of ways we could do that. We can do it on the saw. Alternatively, we can mill a slot in it. I'm very tempted to mill a slot in it. Oh, you know what? I think I have a slitting saw. Ha! Let me go see what I got. Okay, we have our bushing. We verified our fit. We have our boring bar. We verified our fit. And now we're going to cut a slot in the bushing. So what we've dug up is a slotting saw and a slotting arbor. So first thing we notice is that there's some brown stuff here on the saw. Believe it or not, that's leftover from old coolant that I don't use anymore, that left brown sludge on everything, and that was, well, I don't need to mention them. Mentioned them before. The only thing that took that stuff off was isopropyl alcohol. All right, so we're going to go clockwise cutting, which means we're going to be like that, which means the label side down. In case you're wondering, this is a Sierra American SA 1000. This is a very nice fit. The slitting saw itself, one grunt, Thurston Manufacturing Company, Smithfield, Rhode Island, high-speed steel. And I bet you want to know the thickness. 0.30. So there you go. We're going to set up in the mill to put this slit in. Stand by. We're over at the mill. And we're going to figure out how to do this. So the arbor on the slitting saw is 3/4 of an inch, so I have to go get a 3/4 of an inch collet.